On October 6, 2005, a large flammable vapor cloud ignited and exploded at the Formosa Plastics Corporation USA facility in the town of Point Comfort on the Texas Gulf Coast. The accident began when a vehicle struck a valve on a pressurized pipe containing liquid propylene. Flames from the resulting fire reached more than 500 feet high and heavily damaged a large chemical production unit within the plant. The initial explosion knocked several operators to the ground and burned 2 men, 1 seriously. 14 workers sustained minor injuries. Formosa evacuated all personnel from the site. Local officials ordered a shelter-in-place for the Point Comfort community and evacuated students and staff at a nearby elementary school. The U.S. Chemical Safety Board investigated the accident and issued a case study, including findings and safety recommendations. The Point Comfort complex, covering 1,800 acres, is the largest Formosa facility in the U.S. It employs 1,400 full-time workers and 400 contractors. The accident occurred at what is called the Olefins 2 unit, which uses furnaces to convert either natural gas liquids or naphtha into products such as propylene and ethylene.
The fire and explosions at Formosa's Point Comfort plant began with a very simple event in which a valve was struck by a vehicle. But the result was a massive fire that forced a large chemical process unit to shut down for 5 months.
Our investigation focused on how this facility was designed to protect against major fire hazards. We found that improved design practices and protective clothing could have reduced the impact of this accident. The accident occurred on October 6, 2005, inside a chemical process unit with miles of piping, hundreds of valves, and several large vessels containing highly flammable liquids and gases. On the day of the accident, a forklift was towing a trailer loaded with air cylinders used during plant maintenance. Needing to reverse direction, the driver backed the forklift and trailer into an opening between 2 columns supporting a pipe rack. As it pulled forward, the right front corner of the trailer struck a valve protruding from a strainer in a piping system containing high-pressure liquid propylene. The valve was torn from the strainer. Highly flammable propylene began shooting from the nearly 2-inch diameter opening, creating a large pool of liquid and a vapor cloud. The cloud rapidly expanded to engulf a large section of the unit. An operator heard the release, saw the fog-like vapor cloud, and immediately notified the control room. Operators at the control panel began shutting down the unit and venting flammable gases from the pipes and equipment into the flare system where they could be safely burned atop a tower. Meantime, as shown in this pipe schematic, liquid propylene continued to flow from the distillation tower through manual valves to the strainer where the leak occurred. There were no automated valves that could be operated from the control room to shut down the flow of propylene. Operators outside the control room tried to reach the manual valves, but the rapidly growing vapor cloud forced them to retreat. Since the design of the plant did not include remotely controlled valves for isolating equipment, the operators had no way to stop the flow of propylene. Several minutes after the leak began, the vapor cloud ignited. This aerial video, taken by Houston station KHOU-TV, shows how large the fire grew within the first few hours. These pictures show the damage caused by the burning propylene under the pipe rack and under the side of an elevated structure that supported a number of vessels, heat exchangers, and relief valves. As the fire continued, the side of the structure collapsed, crimping pipes leading to the flare system. This prevented gases from being safely burned. Instead, pressurized flammable gases ruptured piping and equipment and burned throughout the unit. The company's emergency response team monitored the fire for 5 days while flammable chemicals in the unit continued to burn. About 7 million gallons of water were used to cool vessels and contain the fire.
The CSB investigation noted that neither of the burned workers had been provided with flame-resistant clothing, even though they worked in an area where flash fires could occur. The propylene piping involved in the accident protruded into an open area. The CSB found the company did not have adequate vehicle impact protection, such as concrete posts to protect pipes and valves.
The CSB found three principal lessons from this accident. Companies should protect vulnerable equipment from vehicle impact, extensively fireproof structures used to support critical piping, and provide workers with flame-resistant clothing to protect them from flash fires. Formosa purchased the design for the olefins unit from an engineering contractor, Kellogg Brown & Root. As specified in the design, some steel beams and columns were fireproofed with a concrete coating, and those survived the fire. However, there wasn't any fireproofing on the structure that supported critical piping to the flare system, and that structure collapsed. The loss of a flare system can lead to excess pressures that burst equipment, causing uncontrolled releases of flammable gases and endangering the lives of people who respond to an emergency. Finally, companies should plan for potential releases of hazardous materials by installing automatic isolation valves at strategic locations. Automatic valves can make the difference between a minor event and a catastrophic loss.
The CSB issued formal safety recommendations to the company, the plant design firm, and a leading industry safety organization. These recommendations are aimed at preventing similar accidents and reducing their consequences. We recommend that Formosa Plastics Corporation USA revise its policies and procedures for analyzing hazards. Hazard analyses should consider vehicle impact dangers, fireproofing of structural steel, and mechanisms for controlling catastrophic chemical releases, such as remotely controlled isolation valves. In addition, we recommend that the company require the use of flame-resistant clothing in units that are at risk of flash fires. We recommend that Kellogg Brown & Root, the company that designed Formosa's facility, use the most current safety standards when designing new facilities, including standards for fireproofing. And we urge a key safety organization, the Center for Chemical Process Safety, to strengthen its hazard evaluation guidelines to include vehicle impact hazards and isolation of equipment during emergencies. As you've seen, a minor event like a vehicle collision can have disastrous consequences if a facility is not fully prepared for a large chemical release. The fires and explosions at Formosa provide compelling reasons to analyze vulnerabilities that could lead to a major chemical accident. For more information about the Formosa Point Comfort accident or other CSB investigations, please visit our website at csb.gov. Thank you for watching this CSB safety video.